Hello, my topic is three-dimensional area and volume measurements for rhinoplasty. My name is Masar Çelikoyer, and I would like to acknowledge my co-authors Oğuzhan Topsakal and Philip Sawyer. Rhinoplasty is a surgery where visible modification in the shape of the nose is the target. And we know that all of the alterations that are being obtained through rhinoplasty can be evaluated in terms of morphometrics. For rhinoplasty, the surgeon tries to achieve a combination of aesthetic harmony within the nose itself, as well as the surrounding facial structures. And that's why facial analysis is an important part of pre-surgery planning. Surgeons have been doing this analysis of the nose and the face mainly by utilizing two-dimensional computer imaging and photography. Measurements that they've been doing were distances between two feature points, angles between 3 points, and ratios were also being utilized. We had a paper published on a collection of the facial surface anthropometric features and measurements with an emphasis on rhinoplasty, and we found that there were more than 122 measurements being done for rhinoplasty. And for examples of these, you could see the figures here about the linear measurements, the angular measurements, and the ratios. We know that nowadays there are software and hardware solutions that were developed to perform facial analysis on 3D scans. The thing is, they are costly and they lack analytical capacity. And we also know that it is possible to calculate areas, volumes, and topographic distances using 3D models. However, for rhinoplasty, there is no such definition for any quantification. Dorsal hump, supratip depression, scroll area, tip bulbosity are commonly used terms that describe some of the nasal deformities for rhinoplasty. And these terms refer to specific shapes with three-dimensional aspects. However, their quantified corresponding analysis are done with the above-mentioned 2D measurements, that is, distances, angles, ratios. For the study, we first of all define which regions of the nose were going to be studied, which are more suitable for area and volume measurements. These, as you can see on the right-hand side, are tip, dorsum, radix, alar base, dorsal hump. We also included the area between the vertical fifths and horizontal thirds of a face and the entire nose. Why we chose them? We know that these are the structures that are being studied from our clinical applications and from the literature search I just presented to you. So we obtained a model, a generic 3D model, and this was in wavefront format and had a texture image in JPEG format. We did all the measurements on this model utilizing the face analyzer tool that's been developed by our team. All the measurements were done in millimeters, so we got millimeter square, millimeter cube. And once we got the model, we had to make some adjustments according to face-based.org, which is being used to define the 3D facial norm statistics. So we made sure that we had one standard deviation of the average values for a 25 years old female. And as I show you in the picture, we decided to call that model GF Pleasant, generic female pleasant. The face analyzer tool that was developed by our team was used to make the measurements. We decided to use 7 different nose types: flat, hooked, short, snub, pointy, large, and saddle nose, as they are representative of some of the most common deformed nose types. Then we morphed the model we had, the GF Pleasant, according to these types, using the free open source 3D modeling software called Blender. GF Pleasant and 7 deformed nose types were, I already said, snub, short, flat, hooked, large, pointy, saddle, can be briefly seen here. And the landmarks we used that define the boundaries of these measurements were all obtained from the literature, from the paper I presented to you, that are being commonly used to define that area. For example, tip defining points were used for tip with the supratip breakpoint and the columellar breakpoint. And for the nasal dorsum, we decided to use the nasion, the supratip breakpoint, tip defining points, nasal parentheses, and so on. For the sake of time, I'm not going to go over all of these, but I can say that these are the landmarks that are being used for those regions in 2D techniques. And this is to show the landmarks and the boundaries used for area measurements. For example, on the upper row left side, we have the alar base shown with the tip defining points, alar base junction areas, and the columellar breakpoint, and so on. And the same landmarks and boundaries were used for volume. However, this time we were using the volume. We were measuring in millimeter cubes. Once we had the landmarks and boundaries well defined, as we had the model in texture format, we marked the texture format in MS with MS Paint, so we could make sure that that area was marked. By the end of this marking, we had 23 red dots representing each landmark used for the measurements. And then the 3D models were loaded into Blender. The area and volume measurements were taken using the add-on 3D print toolbox and Carver. The results we had, we were able to compare all 7 models with GF Pleasant for area measurements and for volume measurements. And to help see the difference between them and GF Pleasant, where GF Pleasant would be shown as the 0 mark on the Y column, all of them had varying significance and differences with the GF Pleasant. And I can show you from here. For example, here we have the GF hooked with the largest dorsal hump, which is expected. And then we have the GF pointy nose with a larger alar base and again a larger tip, in fact the largest tip compared to the Pleasant nose. And then we have the GF snub nose with the smallest volume among all of these noses. So these show us that from the image we have, we were able to visualize that we should be able to get these differences. And yes, with measurements, we're able to show them. For discussion, rhinoplasty results are self-presenting. The outcome nose can be either satisfying or not. However, this is not relying on data, so that's why more data is required to enable the observers and researchers to objectively evaluate the results and possibly relate them to surgical maneuvers and patient-related aspects. Our results indicate that we were able to come up with significant values pointing to the applicability of 3D imaging and measurements for rhinoplasty. We have some limitations. First of all, this study was not done on 3D models of human subjects. It was a generic model. And another limitation was that we used only one model, and that was morphed. We could have used maybe more models and have them morphed maybe. Another limitation is we used feature points while making 3D measurements. Using feature points might make sense for 2D pictures. However, with the 3D models, maybe we may need to come up with better definitions for how to measure that area or that volume. And the last limitation we could think about is that we had just 7 deformity studies. Maybe we could have studied more deformities. That would have helped us. In conclusion, I can say that our study shows that new measurements can be reliably developed for 3D scanned images. Both area and volume measurements are practically possible, and these measurements do find an application for any type of a nose. It is possible to measure and compare the entire nose or certain parts of the nose, for example, tip, dorsal hump, radix. Once the 3D evaluation methods have found their place, it would be possible to do pre- and post-operative analysis and do further deductions that may help direct future studies. Thank you for listening.